In day 13, we're going to look at Apert, and we're going to review some of the ideas from that and from previous sections in this chapter. All right, so review from yesterday, we learned about this number E, and if you don't know what E is, you can find it by typing it into your calculator. And to do that, here's the E button on the left-hand side, and then it'd be E to the first power. Okay, so E, an irrational number like pi, so what that means is it goes on forever. There's no repetition, there's no pattern there, but the first few numbers are here, 2.71828. So let's write that down. Dot, dot, dot. Okay, so we use that when we find things that are continuously compounding. And so that formula for something, if you see it's continuously compounding, is A equals PE to the RT. So let's review what everything stands for. A is the amount after a certain time. P is the starting value, principal, but I'll put the starting amount. E is, of course, this right here. R is your rate as a decimal. And T is your time. Okay, and in these rate problems, we don't add the 1 like we do if it's like annual interest or those types where we do 1 plus the percentage. This one we just use the percentage. So let's plug into A equals PE to the RT, and there's several types. Like, for example, what if you're solving for the amount? And I call that plug and chug because you know everything on the right-hand side, and you just want to solve for A. So Kim invests $4,000 at 3% interest compounded continuously. How much money will she have in 4 years? So here we're given P, we're given R, we're given the time. So we have A equals PE to the R. We have everything that we need. So here's what it looks like. A equals 4,000. E, again, you change your rate to a decimal, but you don't add the 1. And then for 4 years, so times 4. All right, so here's what it looks like. Let's type that into the calculator. So you would type in 4,000 E, and then to the rate, which is 0.03, and then for 4 years, so times 4. And so after 4 years, if it's continuously compounded, here's the amount that you would have, an extra 500, almost 510 to the original amount. So A equals 4,509.99. Okay, so in 4 years, that's how much you will have. That's a lot of interest there. Okay, let's do solving for P. Milo invests some money at 2% compounded continuously. If after 6 years he has $1,691.25, what is his initial investment? So here we want P. We're going to plug in everything that we know. 1691.25 equals PE to the rate, which is 2%, for 6 years. Okay, so here's everything that we know, and we're going to try to solve for P. Okay, so we have right here 1691.25 equals P, and then this is a number, E to the RT. Let's calculate that number. Here's what it looks like. So we'll do E to the power of 0.02 times, what was it, 6 years? Okay, so that is that number. So what we're going to do is we're going to take, and I'm going to leave it in my calculator so we have a more exact answer, but it was, I forgot already, 1.1275. And to get P by itself, then we're going to divide each side by that number. Okay, so in my calculator, here's how you can do it, especially if you have a repeating decimal or something. Here's how you can do it more accurately. So you can do 1691.25 divided by, and instead of typing in this, I'm going to hit Control negative, and that will type in the last answer. This is handy, especially so you don't have to round, and it gives you a more accurate answer. And here's the answer, 1,500. So the starting amount was 1,500. So this would cancel, and we have 1,500 equals P. There was the starting amount before the 6 years was up. All right, how do we solve for R or for T? Okay, so now Rueda wants to double her money. She puts in $5,000 in the bank account that pays 4% compounded continuously. How long will it take her to double her money? Round to the nearest tenth. Okay, so we want to double her money, and she starts with $5,000, so doubling that money would be $10,000. The starting amount would be $5,000. We would have E to the RT, so the rate is 4%, and we want to solve for time. How long would that take to the nearest 10? All right, so we plug in everything we know. Here's what it looks like. What we want to try to do is get E by itself. So the first step is we'll divide each side by 5,000. So we get 2 equals E to the 0.04t. Okay, now that we have the exponent and we want to get t by itself, this is when we have to log it. And if you log both sides with an e, that is the natural log. So we're going to say ln of 2 equals, and taking the natural log brings down the exponent, so 0.04t. Okay, so we'll natural log both sides. This is what happens. And then our last step will divide by 0.4. So now in our calculator, we can type that in, and we'll do ln, which is control e to the x, and it's 2. I'll hit enter, and I'll divide by the 0.04, the 4%, and it says round to the nearest 10, so after 17.3 years, Rueda will double her money. So t equals 17.3 years. Okay, so that's an example of each type. Like, how would you solve for RT? You would do it the same way. How would you solve for P, or how would you solve for A? So you can take a look at this as you do your assignment if you get stuck. So your assignment will be the next 2 pages.